What is this electromagnetic spectrum? According to Wikipedia, the electromagnetic spectrum is the collective term for all known frequencies and the linked wavelengths of the known photons. The electromagnetic spectrum, an object, has a different meaning and is instead the characteristic distribution of electromagnetic radiation emitted or observed by the particular object. But what is it for a simple common human? For a simple common human, it can be said as a long table in which we can find different kinds of rays at the different frequencies and wavelengths so that we can easily arrange themselves and use them for our common perception. Now, if this electromagnetic spectrum is there, then how did it come from where and from how? And for this, we need to turn the page and look into the history of the electromagnetic spectrum. Now, talking of the history of electromagnetic spectrum, we need to know that the ancient Greeks were the first to know about the light traveling in a straight line, and the light consists of various types of different colors. The first discovery of electromagnetic radiation was done by the infrared radiation in 1800 by William Herschel, who was a British scientist. He discovered infrared radiation using a prism where he was measuring the temperatures of different lights, and he saw that the increase in temperature came after the red light or the wavelength which was lower than that of the red, and this red radiation he called the infrared. In the next year only, John Britter, British scientist, again discovered the ultraviolet radiation, working at the other end of the spectrum. He called these the chemical rays because these rays, when thrown upon a chemical reaction, gave another chemical reaction, and thus were called the UV rays or the ultraviolet rays. The first electromagnetic radiation was linked with the electromagnetism by a well-known British scientist in 1845 called Michael Faraday. Michael Faraday was a British scientist who was developed in the field of electromagnetism, electric field, and such stuff like that. He did an experiment in which he polarized light using magnetic field and thus led to the term of polarization and included electromagnetic radiation with electromagnetism. In 1816s, James Clerk Maxwell, this guy here, was the first to develop four partial differential equations in the electromagnetic field, and he, using these differential equations, found out that there are infinite number of solutions for the frequency for an electromagnetic radiation. This was the first indication of the existence of the entire electromagnetic spectrum. Now, Maxwell predicted waves which were at lower frequency than the infrared radiations, as well as at higher frequency than the ultraviolet radiation. In 1886, a physicist, Henry Hertz, built an apparatus to generate or detect what now called the radio waves and the microwaves, and these also travel at the speed of light. Henry Hertz was the first to discover wireless telegraph as well as the radio, and thus helped us to communicate long distance without any problem. Similarly, in 1895, William Röntgen, another British scientist, noticed a new type of radiation that emitted during an experiment with the evacuated tube subjected to high voltage. He could not detect the properties of the radiation and thus named them X-rays. He also found out that this radiation, when thrown only on a human body, gave them the build-up of the body or gave them the bone structure of that body. That means that these X-rays could travel to the parts of the human body but were reflected and stopped by denser matters such as bones. The last portion of the electromagnetic spectrum is the gamma ray portion. The gamma rays were discovered in 1900 by a scientist named Paul Willard, who used an atom of radium to say the radioactivity. In this atom did release some radioactive matter, and these were called gamma rays. In 1910, British physicist William Henry Bragg demonstrated that gamma rays are electromagnetic radiation and not particles, and in 1914, Ernest Rutherford, who had named them gamma rays in 1903 when he realized that they were fundamentally different from charged alpha and beta particles, and Edward Andrade measured their wavelengths and found that gamma rays were similar to X-rays but with shorter wavelengths and higher frequencies. So this way, we have now our own electromagnetic spectrum, which looks something like this. And in this, the increasing frequency and the decreasing wavelength is very well seen. The visible spectrum or the visible light is a very short part of all this electromagnetic spectrum. The range of the electromagnetic spectrum nearly ranges from 2.4 into 10 to the 23 Hz to an ionic interstellar medium of, let's say, around 1000 kilohertz. So this is a normal electromagnetic spectrum that we have. This electromagnetic spectrum helps us in the perception of different types of radiation that we have and for various types of phenomena that are linked with these types of radiation. If we consider radio waves, then the collective oscillation of charge carriers in bulk matter, that is the plasma oscillation, is a radio wave. Similarly, if we talk about microwave radiation, then we all know that microwave radiations are just another type of radiation which we use on a daily basis. This is a microwave that we have, and in the microwave, if the name suggests, we use microwaves. So, if we have a build-up of popcorns moving about in this, and then microwaves are the ones that are building those popcorns. Similarly are the visible light, which helps us in viewing the objects around us in the world. If we talk about ultraviolet rays, then ultraviolet rays are mainly due to the excitation of molecular and atomic valence electrons, and these is also the main interactions with the matter. X-rays are caused by the excitation and ejection of core atomic electrons and also lead to the quantum scattering. Similarly, gamma rays are also a measure of quantum scattering and energetic ejection of core electrons into heavy elements. High energy gamma rays are caused by the radioactivity of various types of element above uranium. So, if we have a radioactive element like plutonium or radium, then these obviously give us some kind of high penetrating power energy rays, which are called the gamma rays. So, the electromagnetic spectrum is a normal list of different types of radiation for the perception of the common man.